mechanism, but what I learned recently is that it's only part of the consensus mechanism. And I think the way that they separated block production from finality is super interesting.
Hmm.
So what
Hi,
is
Jay.
Hey guys.
Hey, Jay.
Hi.
Hey, so what is the relationship between substrate and Polkadot?
Yeah, that's a good question. So Substrate is basically like a framework on which that you can use to build blockchains. So like if you imagine you want to create a custom blockchain that does one specific thing, so maybe it's a cryptocurrency, or maybe it's a DApp like CryptoKitties, or maybe it's a decentralized ID solution, whatever it is, you can use Substrate to quickly spin up your own custom blockchains. And the basic idea is that like there's a lot of stuff that looks the same in every blockchain. So like, you know, peer-to-peer gossip network, for example, some form of decentralized consensus. And in general, you might not care or even want to write all that stuff yourself. It would just take a lot of time. What you really care about is writing your own like runtime logic. And so you can use Substrate for that. And
yeah,
then,
Substrate is also so modular that I think the consensus is actually just one of the modules. So you could actually just write a lot of different distributed applications, and you could even take out the consensus module if you want and write something that's not even a blockchain.
yeah, so that's one thing I really want to dig in on that I don't feel like my head is wrapped around yet, like how you can hot swap or maybe not hot swap, but like easily swap out different consensus mechanisms. And like I'd be interested in coding some, or like you said, making one that's like so different it's not really even a blockchain. Have you done it, Jay? I saw you participating in GitHub on GitHub in the Substrate collectibles workshop. I didn't know you had done that until yesterday. Have you worked through it?
Yeah, I worked through it a while back. I don't know how much it's changed.
Yeah.
But yeah, it's a good workshop.
Yeah, nice. So Jim was asking, right as you were hopping on, Jim was asking about the difference between Substrate and Polkadot, I guess. And so I think Polkadot is basically like one thing that's built on Substrate, and it's supposed to be kind of like Cosmos, where it's like interchain communication. And one of the cool things Polkadot has is shared consensus. So like your specific use case specific blockchain doesn't have to like have critical mass of miners or validators to make it secure. You can share consensus with all of the other chains in the Polkadot network. So that's a bit about the relationship there.
So there is also some kind of storage mechanism on Substrate, right?
Yeah, that's right. And I don't know very much under the hood, like how it works or anything. But what I know from the tutorials I've done is that when you're writing your runtime module, you can kind of take it for granted that that thing is there and working. So you basically declare like, so like, for example, imagine you're making something that looks a lot like an ERC20 token. You basically declare, okay, storage layer, I'm going to need a mapping from account IDs to token balances, and then you have it.
I see.
Yeah.
Yeah. I also know that they've implemented both the Bitcoin protocol and Ethereum on Substrate, which means that you can store things as UTXOs and also as storage accounts.
Yeah, there's a really cool UTXO workshop too that I haven't gone through yet, but it's in a similar style like the CryptoKitties clone was. So I'm looking forward to doing that one.
Nice.
Yeah, but I will tell you guys, like so anytime you move to a new blockchain, like there's a million cool things to learn, right? But the one thing that I feel like is missing is like valuing concurrency. Like coming from our chain, it's all about concurrency, and I feel like I haven't heard of much or seen much about that over here yet. Yeah.
So is there any like a language on top of the Substrate, or how do you?
Yeah. So you're saying so you're saying like Solidity is to Ethereum as Rolang is to our chain as like what is to Substrate? Like, is that the question?
Yeah. If it makes sense.
Yeah, well, so the first answer is that doesn't totally make sense because their
Hmm.
model's a little bit different. And instead of like deploying contracts onto a blockchain, instead, like whatever your application is, the blockchain is specific to that application. So you basically take like their libraries that are written in Rust, you also write Rust, and then you compile your whole like blockchain node basically. So then the blockchain, so like basically they've written most of the code for you. You write the little bit that you care about all in Rust, and then you compile it and you get like a, Tomislav chain node.
Oh, I see.
Yeah.
Yeah, and it doesn't even have to be Rust because the runtime is in WebAssembly. So that's like the core. Whatever you can compile to their WebAssembly architecture can run in Substrate.
Yeah. I forgot about that. Yeah, that's super cool. In practice, it seems like most of them are doing Rust. I would love
Yeah,
to help
absolutely.
spread that out a little bit.
Yeah.
But the other part
Mm.
of the answer to that question, Tomislav, is like, well, if I can, write anything I want in Rust and make it the runtime of my blockchain, there's no reason I can't write a smart contracting platform that would use Rolang or Solidity or whatever else. And they are writing one that is still in development. Like it works kind of, but it's not production ready. The language is called Ink, INK exclamation point.
And what is it for exactly?
It's a smart contracting language. So like basically you
Mm.
put together your runtime, and it include, like you were saying, Jay, it's super modular. And so there's one of these modules you can use that's called contracts. And if you have that module in your runtime, then you can actually deploy smart contracts just like you would on Ethereum or Archain or wherever.
Hmm.
And so Ink is there. I'm not really clear if it's like its own language that looks a ton like Rust, or if it's like a subset of Rust, or how that works exactly. But it definitely looks and feels a lot like Rust.
Mm. And you can use Substrate is like some kind of a library that you use, and you build upon it, and right, and you use it as a storage is in a blockchain. This is what you get from Substrate, right? And
Yeah.
this your extension for your blockchain is also stored on the chain, right? As a transition of your virtual machine of your code. In this sense, the contract is like your code. You're saving it on existing blockchain. Is this?
Yeah, I would say it's like that. It's like you're writing a couple smart contracts, but they're in the Genesis, and you have maybe more powers than you would in a normal smart contract. But you're basically just writing the state transition function for the chain, and everything else is kind of provided by Substrate by default.
Yeah.
So you have like a you have from Substrate you get this basic support, and then you build on top of that. You extending this with smart contracts or whatever you want to have on the chain.
Yeah.
Oh, cool.
Yeah, that's right.
Yeah, and their idea. So then the idea with Polkadot is like, since they're using that model where you basically like write your own blockchain node for your application, then it's already important, but in that situation, it's even more important to have interchain communication so that, like my collectibles app we can trade the collectibles against the cryptocurrency that you created, and govern the monetary policy by this DAO that Jay created or whatever. So that's what Polkadot is for.
Do you know much about how that works?
No, you pretty much heard my understanding of it just now, to be honest. Yeah. I'm hoping to learn though, obviously.
Yeah. And what about Grandpa? Have you looked into that?
Yeah, right. So that's what I was kind of hoping to talk about today, but it would definitely be very much like, all of us learning together. I don't feel like I can present it as someone who fully understands it or anything, but I did have a little study session with my new colleague Nicole. I was hoping she would join us today, but I can see over there she's busy with other people. But so like here's some basic things that I've discovered, and then we can kind of like look through the paper together. In fact, maybe I'll try to share that right now. Here's the paper. So the biggest thing that is standing out is that they're separating these two concepts that I just never even realized or considered could be separated. And they're separating block production, like creating new blocks and gossiping them around the network, into a totally separate thing or not totally separate, but loosely coupled thing with finality. And I didn't realize it until looking at this paper, but it's kind of a similar idea to like the ETH 2.0 design, where in ETH 2.0, they're using proof of work to build, mine blocks, just like they always have been. But then they're using, in ETH 2, they're using Casper, the friendly finality gadget, to like get finality over blocks. And so in this world, they're using something called Babe, which I literally don't know anything about, to create the blocks. And then they're using this grandpa thing to establish finality over them. For some reason, I can't view this file the way I expected, but maybe we'll get it this way. I'll put it there where everything goes. So, let's see.
So Joshi, are you working for Parity now?
I am. I just started. Yeah.
Nice. That's awesome.
Yeah. Thanks, man. I appreciate it. So we'll have a lot more Rust in common questions to talk about. Oh, what did you think about my very humble beginnings of Rolang?
Oh, yeah. It's good that you figured out the infinite types thing with Rust as point.
Yeah. Is box the right way to do that?
Yeah, it definitely is. You don't even necessarily have to have an enum data structure to kind of store it recursively. I mean, it depends on how you want to do it, but I think there's generally a more efficient way that people like to write abstract data types in Rust. I'll pull one up.
Do you want to take the screen share for a sec?
Yeah, I have a file somewhere on my computer. I can look around for it.
Okay. Yeah. Cool. Yeah, it's another thing that's new to me that I haven't really encountered, because I guess I've just always programmed like more high level languages, is you have to kind of have in your mind an understanding of like memory on the stack versus memory on the heap. And I feel like that's always been kind of abstracted out of my presence of mind in other languages.
Yeah, well, in my opinion, it's a great thing to keep in mind, and whenever you're programming on a computer, because that's the reality is, we are programming on imperative machines.
Yeah. I'm definitely not anti. It's just something new that I've been, wrapping my head around.
Yeah.
Well, let's see. Maybe in the meantime, we can start to look at some of this grandpa stuff. So some of it looks, I skipped over the introduction, but so they say we want to formalize the notion of a finality gadget. And so like Casper, the friendly finality gadget, is another one. And later in here, they even have a section called like comparison to Casper.
Oh, cool.
And I think it's Casper FFG, not our Casper CBC that we're more familiar with. And so we're going to need to incorporate into the definition of Byzantine agreement that we have access to a protocol that would achieve eventual consistency if we did not affect it. So this is basically like one of the key ideas. So they're saying like, we're going to use this grandpa game to finalize blocks. Like when, based on grandpa, which we're about to explain, we'll be able to know, is some block final? Like, is this block going to ultimately be in the blockchain? But grandpa can't work on its own. It needs, along with it, this block production mechanism that works kind of like Bitcoin's proof of work, where like, as the proof of work chain keeps growing, you can say about any block, like this one is 10% likely to be in the final chain, or 80% or whatever. And the deeper into the chain you go, the more likely it is going to be to finally be there. And so that like probability of finality based on the block production mechanism is going to be like the heuristic that they're going to use to like initialize the values in grandpa. So basically, like, you know, when we were playing those Casper games, like writing out example ones, basically everyone has to start with some initial value that they, whatever the domain is that we're trying to come to consensus on, everybody has some initial value. And what the change that they make is they say, instead of everyone just having their own initial value from somewhere that they like made up or whatever, the place, instead of that, what you have is this oracle that you can query to say, what's the best block so far? And that oracle is your block production mechanism, your proof of work or your babe or whatever it is.
And it also can be a proof of stake, right?
That's a great question. I think the answer is yes, but I don't really know. So well, let's see how they described it here. They said, we need to incorporate into the definition of Byzantine agreement that we have access to a protocol that would achieve eventual consensus if we did not affect it. So I think as long as we meet those criteria, probably we're good.
I think the example below is proof of stake.
This one in definition 1.1?
I'm talking about grandpa.
And
Oh,
what does it mean if we did not affect it?
yeah, that's a good question. I know that there's an interplay between grandpa and babe, the block production mechanism, and they affect one another. And so I think they're saying, like, if we just let babe run on its own without this interaction, we would have this like probabilistic emergent consensus, like in the same way that you have it in Bitcoin. And that it has to have that all by itself, even apart from any interactions that we have with it from the grandpa side.
Okay.
So they say we have a set of participants V for, I don't know if that stands for voters or validators, but we're calling them V, the majority of whom obey the protocol, but a constant fraction may be Byzantine, which means the same thing as always. They can go offline, or they can lie, or they can equivocate, or whatever. So, and maybe before we dig into these, just to give you a sense of how these definitions work, they basically like define a game with certain properties, and then they like redefine it with slightly different properties, and then redefine it with slightly different properties. And this is basically the one that I think is finally what they're calling grandpa.
Let me just show you this quickly here. The example in the Medium paper.
Oh yeah, I forgot about that. Yeah.
Which shows staking, and you know, basically, apparently, when they finalize the blocks that have 2/3 of the votes, as soon as they get 2/3 of the votes, they're finalized. But I know there's more to it than that.
Yeah, but that's a super important point, right? I think that's the same 2/3 that we got, that we've seen a couple times when we're talking about. I don't even remember if that comes from like Byzantine fault tolerance or where that came from, but
yeah,
it's the thing about like the bad guys can try to partition the good guys into two sections, and then if more than a third of the total people are bad guys, then splitting the good guys in half means that the bad guys are bigger than either half.
Right. Yeah. So here, you know, your stake determines the number of votes that you have. It's basically a voting system.
Yeah. Yeah, which is like pretty much the same as what we saw in CBC Casper too.
I guess you know, if you have some number of votes and two-thirds of them say that the grandfather block is final, you know, is
Yeah.
good, then it's finalized.
Yeah. Yeah.
So do you know their reason for creating Grandpa? Like what they're trying to solve?
Oh, that's a really good question. I know for sure that one thing they're trying to solve is the problem of finality. Like we want to be able to say more than just with arbitrarily high probability, but we want to be able to say with certainty that this block is in the chain. You know, like that block where I paid for whatever is not going to be reverted. So that's maybe it says in the introduction. Yeah, what were you thinking of?
Well, I don't know. I'm just thinking, you know, why didn't they use like Casper or one of the existing finality gadgets?
So let's see. So this might be relevant.
I'm thinking in terms of synchronization. So because you get safety with 2/3, but you don't have liveness. You need some kind of synchrony constraint. And is this Grandpa protocol like some kind of synchronization constraint?
I think they're trying to isolate
so that you can
from synchronization, so that they have a finality mechanism.
I was thinking that in a synchronous network, when you apply some kind of synchrony constraint, you get aliveness or finality.
So let's see, they're saying this here. They're presenting their finality gadget that works in a partially synchronous network model and can tolerate 1/3 Byzantine actors, as well as an asynchronous finality gadget that can cope with 1/5 Byzantine actors. It almost sounds like this one that's totally asynchronous is not Grandpa, though, based on the way they phrased that.
Yeah.
But it's interesting that they say asynchronous finality.
Yeah, and I'm curious to see where this number comes from too. I haven't seen that before kicking around in distributed consensus. Well, do you want to just dive in on one of these, like one of their first examples here?
Let's do it.
Okay. So a protocol for a multi-valued Byzantine agreement has a set of values S, a set of voters V, a constant fraction of which may be Byzantine, for which each voter starts with an initial value. Yeah, so this is the initial values that I was talking about, and in the end decides a final value with these properties. So we care that all of the people who played by the rules end up deciding on the same thing. So there's no way that like one of us says, okay, we agreed on A, and the other one says we agreed on B, unless one of those disagreeers is not an honest voter. Termination, we eventually come to some agreement. We eventually decide on a final value. And then validity, if all the honest voters have the same initial value, then that's the one we decide on. So I was thinking about, like, you know, when we first started these a couple months ago, we talked about like integer consensus. And so I guess this one means that, like, you know, if we all are here playing by the rules and we all chose some integer to start with, like one of our integers that we chose to start with has to be the final one that we all agree on. We can't somehow like come up with a different, oh no, maybe that's not what that says. This says if they all have the same initial value, then they decide on that value. Yeah.
Yeah, it's pretty weird. Seems like an opinionation on like the state transition.
Yeah.
Yeah.
Okay, we can change this definition to assume that instead of having an initial value, all voters have access to an external protocol, an oracle of values that achieves eventual consensus in that it returns the same value to all voters when called after some time. So that almost sounds to me like whatever this oracle is that they're bringing in, like if we call it and call it and call it and call it, it might give us different, like it might oscillate and kind of change its mind at the beginning, but then like eventually it stabilizes.
Yeah, they call the partially synchronous is that there is a known global stabilization time.
Yeah, Jim, can you share that again? I found that insightful and never saw it before that Medium post.
Yeah, that's where I saw it. That's where it is in the Medium post. So I guess you can reasonably expect to see a block in some time, 10 seconds from anywhere on the network. And then messages are delivered within T after that. So they're using so there is a possibility if this time is set too short for them to lose safety, and that you could finalize blocks and then later change your mind as you get more information. But assuming that you've gotten 90% or some percentage of the messages within that global stabilization time, you have safety and you have finality to a certain extent. No, you don't. Finality is separate, but that's so
And what is global stabilization time? And what is Oracle?
I think an oracle is something that you can just ask a question and it gives you an answer, and it's like by definition the right answer. Like I think the oracle is like something that you're deciding that you can trust. Like that's part of how we're considering it.
And the oracle has your personal state, but not the state of everyone? Or does it have the state of everyone?
That I don't know. That's a good question.
The oracle doesn't need to have any state in itself. It's like when you're, let's say you're trusting another blockchain for the answer. That would be an oracle. Or if you have a clock that's external to the system, that would be an oracle.
Yeah.
I guess the criteria there is that everyone talks to the same oracle, whatever that is. It's something outside the system.
Yeah, I think outside the system is a key part there, right? Like it's something that exists separate from whatever game we're describing, and we're just taking it for granted that it's giving us the real thing. Like another example where I've heard that is when you talk about like on-chain token exchanges or whatever, they sometimes talk about price oracles. Like if you want to have a real-time understanding of like what the price of some token is in fiat, then that has to come in from outside the blockchain.
Mm-hmm.
Or like in these on-chain sports books, like most of the logic can be on-chain, placing your bets, deciding on odds, enforcing the payouts. But the one thing that has to have an oracle is who actually won the sports game that you're betting on.
I see. And I see that the need to have oracle if you accessing something outside the chain. But if you're describing something that is on chain and you're depend on an oracle, it seems like counterintuitive to me.
It doesn't say you're depending on the oracle, but there's just stating, I think it's just the reality that we use oracles. So they're covering that case.
Yeah, I think in this case, it really just matters what questions we're asking the oracle. Because if you're asking, is my value the consensus value, or do I need to change it? Then it would need to know the state of everyone else.
Oh, that's a great point. Yeah, that's a great point.
But I'm thinking that where do you run Oracle? On which machines? If this is only one machine, then you have a centralized thing that you depend on. And if this is the centralized machine, how you make consensus on these decentralized machines?
Yeah, so here's my understanding from having skimmed only slightly more of this paper than we've looked at. So realize that this could be totally wrong. But my working hypothesis is that when we say oracle in this specific paper, since this is the grandpa paper, oracle means external to grandpa, not necessarily external to the whole blockchain or to the peer-to-peer network, but it's just something that exists outside of grandpa itself.
I see.
Yeah, and then I think, like I was starting to get at earlier, I think what the oracle is going to end up being is this this block production mechanism with eventual or probabilistic consistency. And then the questions we'll ask it are like, so like, since I don't really understand Babe or the parity model as well yet, like if we think about the Ethereum 2.0 model, then you can think about like Casper FFG querying the oracle, which is the proof of work system, and saying like, hey, proof of work system, based on all the blocks you've seen and the hashes and everything, like what's the best block so far? You know, what's the tip of the longest chain? Like according to the old rules, what's the best block? And now let us add this new game on top to establish finality.
I see.
Yeah,
So in a sense, oracle.
Yeah, there would be an oracle in the other direction as well, and grandpa determining the finalized block, and that would get the consensus mechanism.
Yeah, and that comes up in here later too, because we do have to slightly modify the old eventually consistent one, because like the whole thing with proof of work is that if an attacker has some long private chain that they've been hiding, at any point they could release it and everyone would have this huge reorganization. So we have to change it so that it plays by the same old proof of work rules, with the one exception that the last finalized block is always in the chain. You know, like we can't reorg arbitrarily deeply anymore. I just realized I'm not sharing this anymore.
So you said sorry. I'm processing what you said. Last finalized block is always on the chain. Is this what you said?
Yeah. So I think we have this block production mechanism like proof of work that's playing by its normal rules, right? But it's also interacting with this other thing like Casper FFG or grandpa. And so the only little adjustment we have to make to proof of work is to say, you'll never reorg any deeper than this block that grandpa is telling you is finalized.
Oh, I see. Oh, okay. Like you're labeling all the nodes that will that can never change.
Exactly. So it still does the same proof of work. It still does the same longest chain rule as always, but it almost treats like the last finalized block as sort of like a genesis in some sense. Like you can't reorg any deeper than that, any farther back in time.
Cool. Thanks.
Yeah, you're welcome. Remember that's all my working understanding, which could be wrong.
yeah, but now I have a better understanding, of the whole story. You know.
Yeah. Right.
It's two different protocols, and one is like dependent on the other. Yeah. Okay.
Yeah.
Cool.
Okay. So definition 1.2, we say an oracle A in a protocol is eventually consistent if it returns the same value to all participants after some unspecified time. So that almost sounds like the global stabilization time that we were talking about.
Yeah. It reminds me to Casanova and their time.
Yeah.
Maybe.
Yeah, that parameter that is some fixed amount of time. We don't know what it is, but definitely there's some.
Yeah.
Okay, 1.3. A protocol for the multi-valued Byzantine finality gadget problem has a set of values S, a set of voters V. Oh, it is voters V. A constant. Yes, some of them could be Byzantine. Each voter has access to an eventually consistent oracle A, and in the end, each voter decides a final value FV, such that the following. Yeah, and so it's super similar to before. All honest voters decide on the same thing. We're able to decide eventually. The game won't go on forever. And all honest voters decide a value that A returned to some honest voter sometime.
So you ask Oracle and you search for initial value, right? You as a voter.
Yeah.
And
Yeah.
Oracle gives you something, but you don't know is this the correct value or not.
I think that's right. I'm thinking of this as like, when we query the Oracle, we're basically saying like, hey, proof of work thing, what's the best block so far? And then if you wait 20 minutes and ask again, it might say something different because there's more blocks.
Yeah.
Yeah.
Can you use this value as an initial value for you will know is it final or not, right?
Yeah, I think that's a good question. I mean, yeah, I
But
guess.
you
Yeah, I
know how
guess
many voters, right? You get from Oracle's number of voters for this value, or
I don't think the Oracle tells you that. So remember the voters V, this is the setup for grandpa, right? These voters are just like in CBC Casper, you know your whole set of validators, your whole set of players in the game. But the Oracle, I think all you're asking it is, dear Oracle, what's the best block so far? I think that's it. And I think, like if it's proof of work, the way it calculates that is just like the longest chain rule or ghost or something else fancy like that. But not something that's like based on the votes, not something that is based on grandpa.
Well, basically you want to ask, you need to know, or at least be able to determine if a particular block has 2/3 of the vote. So there could be 3 votes beyond that. This could be the grandfather block that you want to know about, not the current chain.
Yeah, I think I agree that that's all stuff we want to know and can know, but I don't think that's what the Oracle tells us. I think most of that information comes from within grandpa itself. Because like we're all passing these votes around to one another and gossiping them just like we did in CBC Casper. When I cast my vote that like, block Z is the block that I want to vote on. Like you guys all know, all the other voters know that, independent of whether the Oracle told them, because I told everybody directly what I'm voting for.
I guess my problem with that is that, every time you call the Oracle, the chain is growing and you're going to get a different answer.
Yeah, I totally agree. And so I think that's why they're kind of saying like, this language sounds almost like hilarious because it's so general, but so they're saying like the voters will decide on a value that the Oracle returned to one of us at some time. It might not have been returned to me, it might have been returned to someone else, and it might not have even been returned to them recently. But at some point the Oracle said like, this is my current best block.
Yeah, so we just don't have the concept of finality at all yet. Like this just could continue forever.
Yeah, that's right. Yeah, so the game we're building up here is what's going to give us finality. The Oracle itself does not have finality. In fact, the Oracle has is eventually consistent. Actually, I don't know if I just realized in my head I've been treating eventually consistent and like probabilistic finality as synonyms, and I don't really know if that's correct.
Yeah, I don't know. I mean, it seems like they kind of would be.
Yeah. So, well, okay. Oh yeah, go ahead.
This is you mentioned that they have this separation of consensus. So you get all the votes from other voters, but you don't get all the information from this chain or from this consensus because you are asking Oracle. So I have difficulty to understand what from where Oracle is looking at some, for example, proof of work, but all your votes are not in this chain because you're not looking at this chain. You have You're using votes for something, and for something you ask Oracle.
Mm-hmm. Yeah. Yeah. So let me see, is your question like if we're playing this finality game separate from the blockchain itself, how do we ever record in the blockchain when a block got finalized? Or is it different than that?
Well, I'm not sure where the votes. They're in the
Yeah.
messages also saved on the blockchain, visible to Oracle.
Yeah, I'm not really clear on that. That's a great question.
Well, I understand that now from the Medium article why they give the block, why they give the block, the current block, rather than the grandfather, is because their current vote, the vote on the current, most likely, block, transitively votes on all the blocks, all the ancestor blocks. And
Mm-hmm. That's right, yeah.
and when it gets down to the point where it has 2/3 majority, it finalizes that block, not the lead block.
Yeah.
So the votes are in the same on the same chain.
Right.
So okay.
So the grandpa's just looking at he gets a vote from each person on the lead head block, and they may all be different, but some ancestor gets a majority,
Mm-hmm.
and that one becomes finalized.
But you can also look for yourself, like in hash graph, on all the messages, and you can conclude, okay, this is the majority and this is finalized. But this is not how this is working, because you have Oracle, which have like a special view on the chain, on existing messages.
Yeah. Yeah, so now I'm wondering, now that we've dug into this a little bit, I'm imagining like if I'm a voter in this grandpa protocol, then what do I base my votes on? Is it, like in Casper, my votes are based solely on everybody else's votes. But here I have this additional source of information, A, and I wonder, like, imagine we get in some situation where like the Oracle tells me, hey, I've got this really nice long chain with lots of work behind it. Here's the head block. But meanwhile, all the other voters are voting on some other thing. So I wonder what the rules are about like where I'm supposed to vote.
Yeah.
Okay, so they say for the binary case, and so we used to play a lot of binary consensus, where the size of the possible outcomes is 2, so like true and false. The Byzantine finality gadget problem is reducible to Byzantine agreement. It doesn't hold for bigger sets because the definition of validity is stronger. I'm not really sure what that means.
This means that validity is some kind of a set of possible values.
Yeah.
But it's not only that.
So this is what they defined as their validity condition right here. Well, maybe the question is, what the heck is Byzantine agreement, actually, now that I think about it? Is that like the original Byzantine generals problem or solution to that problem?
And what is exactly the solution?
I don't know.
Sure. Me too.
Okay, well, let's see. Note that it's impossible for a multi-valued Byzantine agreement to make the validity condition require that we decide an initial value of some honest voter and tolerate more than 1 over the size of S fraction of faults, since we may have a 1 over the size of S fraction of voters reporting each initial value, and Byzantine voters can act honestly enough not to be detectable. For finality gadgets, the stronger validity condition is possible, and we will want even stronger versions that quantify when an honest voter had the value. That's a little hard for me to parse right now.
Yeah.
Oh yeah, I read this paragraph before. They talk about some new interesting result. Deterministic binary finality gadget is impossible even with one fault, which is not a consequence of FLP impossibility. 3 is FLP. So maybe we can pick back up here. Let's see how that goes. So how do we extend this to agreeing on a chain of blocks? One difficulty in formalizing the problem is that the block production mechanism cannot be entirely separate from the finality gadget. In order to finalize new blocks, we must first build on the chains we've already finalized. So at a minimum, the block production mechanism, we will also allow the block production mechanism to interact with the state of the finality gadget in other ways. So this part, I think, is what I was talking about earlier, where the block production mechanism needs to know when something gets finalized so that it can, you know, not reorg deeper than that.
Yeah.
I'm not really sure what the other ways are, but it sounds like we'll find out soon. So we want the finality gadget to work with the most general block production mechanisms as possible. Thus, we need a condition that combines the property of eventual consensus. Yeah, I think maybe I've confused eventual consensus with eventual consistency. I don't know if those are the same or not.
Yeah, this is a good question.
So, okay, so we need a condition that combines the property of eventual consensus, and this is and this requirement to build on the last finalized block, but it's otherwise not too restrictive. We assume a kind of conditional eventual consensus. If we keep building on our last finalized block B and don't finalize any new blocks, then eventually we have consensus on a longer chain than just B, which the finality gadget can use to finalize another block. We also want a protocol that does not terminate, but instead keeps on finalizing more blocks. Okay.
So my first question is
terminate.
So I think in these above games that we talked about here, we're playing a game to decide on like a final answer. Like you know, the example I used to give is like, hey, we're all going to go to dinner tonight somewhere, and people have different opinions where we're going to go, and we need to decide. And then once that game terminates, then we actually go there for dinner. But I think down here, what they're saying is like, well, we're trying to generalize this to a blockchain. We don't want to just like finalize a block at height 10 and then call it a day. Like we want this thing to keep going and going and growing, like let the chain grow longer and longer.
Okay, gotcha.
And yeah, go ahead.
I have a question about this building on finalized block.
Yeah.
But you want to build before you know this block is finalized on this block, because if you must wait to confirmation to that this block is final, how can you you will be building only not a deck. You will build just one chain.
Yeah,
this is all about chains.
If your current fork choice doesn't include a finalized block, then you have to change your current fork choice to one that does include the finalized block.
And then, Josh, you're saying this is a chain, not a deck.
Yeah. Well, so like it's a tree. Like blockchains are always like a tree, really, but we're trying to choose the best branch in the tree, which we then call the chain. Yeah. Remember, I was saying I miss all of the concurrency talk. So yeah, we're very much blockchain here. So there's no like block merging. Every block has one parent.
Okay.
Yeah.
Okay. Then this makes sense.
Yeah. Well, so once we understand this, our original work can be generalizing it to block DAG consensus. So. So, okay, we also want a protocol that doesn't terminate, but instead keeps on finalizing more blocks. Okay. So, so here we go. We assume there's a block production protocol P that runs at the same time as the finality gadget G. So G is the gadget or grandpa, and P is this like proof of work thing. Actors who are participants in both protocols may behave differently in P depending on what happened in G. However, in the reverse direction, the only way an honest voter V's behavior in G, so I think that means like, maybe just taking the first sentence, if I'm mining the blocks, I can choose to mine on a different fork based on just exactly what Jim said. Like I saw that G finalized some block, now I'm going to start mining on it because I know it's finalized. But in the reverse direction, the only way I would behave different in Grandpa, the finality gadget, based on what happened in the block production mechanism, is through a voting rule, this function that they call A. And remember, A is what they called the oracle earlier. And it takes 3 parameters, which is V, the voter, 8, SV. Based on the subscript V, I think this means the state of the voter, not the state of A itself. And finally, it takes a block B and returns a block B prime at the head of a chain, including B. Oh, the voting rule function. So maybe this is the thing I was asking about earlier that tells me, like, as a participant in Grandpa, how I should vote.
So I'm wondering why do you need external oracle if you have all the information that you can look on P? So A is not dependent on P. Affected by P is true voting rule. Oh, block B is on P, right?
Yeah, but that's it. Oh, I mean, I guess if you have B, you have that one path all the way back. Not sure.
Yeah, like you're saying like all of its ancestors recursively.
Yeah.
Right. Yeah.
Yeah, it's just a separation of responsibility, right? The oracle represents the independent process.
Mm-hmm.
I mean, it's dependent in the sense that both are aware of the chain,
Mm-hmm.
of the blocks and their ancestors.
Mm-hmm. Mm-hmm. Okay. Okay, so we've got this voting rule. Yeah, go ahead. Go ahead.
But this A is not running on your machine, right? I'm trying to place this oracle somewhere.
That's a good question. I don't know. One possibility is that A is just like an algorithm that we've all agreed on. And so like I can run it on my system, and then when you see my vote, you can confirm that I did it correctly. I'm not sure if that's what it actually means though.
Could it basically just be the state transition function?
So let's see. It says the only way a voter's behavior in the finality gadget is affected by the block production mechanism is through this voting rule. So this thing is supposed to be telling me like how the block production can affect the way I vote in Grandpa, I think. And yeah, the state transition.
Yeah, but the takes a block and returns a new block B prime.
Right. Right.
Is it similar to estimator function?
That's what I was just wondering.
Yeah, so you're looking at the history. Yeah.
What did our estimator take in CBC Casper? What information?
A sender, a power set of messages, and what else?
Some subset of all the messages, right?
Yeah. Yeah, all the messages.
All the messages you've seen, I guess.
Yeah.
Yeah. Yeah, maybe that was it. I guess maybe that was it. Yeah, I also feel like SV wasn't totally clearly defined.
In next paragraph, it says SV will contain the same descendant B prime of B.
Oh, yeah, okay. So the system, go ahead.
So SV is blocks or
Yeah. I'm going to scroll a little bit just to see where the next section starts. Oh, soon. We're not doing too bad.
cool.
Yeah. I almost wonder if we should just go through definition 1.4 and then pivot topics a little bit and each read a little more.
Yeah.
All right, so let's see what 1.4 is, because I think 1.4 is cool because now we're getting to the properties that we actually care about for a chain that keeps growing.
Yeah.
So, all right, so let F be a protocol with all these voters. Some of them might be Byzantine. F solves the blockchain Byzantine finality gadget problem, which I think is what they were just defining earlier. If for every block production protocol P, a voting rule A, and maybe that's supposed to say and voting rule A, then we have the following. All honest voters finalize the same block at each block number. Oh, so this seems like a generalization of agreement. Because here we were saying like we decide on the same thing, end of story. Here we're saying we decide on the same thing for each block height. Liveness, if the system FGA achieves conditional eventual consensus, then all honest voters keep finalizing blocks. What was the one before? Oh, termination. Oh, it's like the opposite of termination, actually.
Yeah.
And validity, if an honest voter finalizes a block B, then that block was seen in the best chain observed by some honest voter containing some previously finalized ancestor of B. So I think this is really similar to all honest voters decide on a value that the oracle returned to some voter at some time. So if we finalize B, that means like if we decide on B, then earlier we said that B must have been given by the oracle to someone at some time. And here they say that block was seen in the best chain observed by some honest voter containing some previously finalized block B. Oh, ancestor of B. Yeah, I think this is almost the same, saying almost the same thing. Like if we finalize B, then the oracle must have, wait, that block was seen in the best chain. I think seen in the best chain is equivalent of the proof of work oracle told it to us. Seen in the best chain observed. Jim, can you show that Medium article again? Oh. Hey, Jim, do you have that Medium article handy? Oh, nice. Oh, yeah, nice.
Oh, you're muted, Jim.
We have A, B, and C finalized. Okay, and then we have a D1 and a D2 here. And this one has 4 votes, and this one has 11 votes.
Mm-hmm.
So it's not finalized yet. It needs, we need a 12th vote to become block D.
Mm. No, oh, no. 2/3. We need 2/3 votes, right? So in this scenario, there's only 15 votes.
Oh, okay.
So then
I wasn't adding the 4.
Yeah.
Yeah, it's 15. So it can. So now block D gets finalized,
Yeah, right. So that makes sense.
and
So,
then
okay, so yeah, go ahead.
once everyone knows block D is finalized, they no longer need to consider forks that don't have block D2 on them.
Right. So like that block D1, for example, is out.
Right.
Okay, so validity says, looking at this figure maybe will help us. It says if an honest voter finalizes a block B, so let's just say like if an honest voter finalizes a block D2, then that block was seen in the best chain observed by some honest voter containing some previously finalized ancestor of B. Yeah, oh, and it totally was. Node 2 and node 3 both saw that block D2 in the best chain, in what they considered the best chain of a previously finalized ancestor, like, for example, C or B or something.
Yeah.
So, yeah, maybe with the figure, that doesn't seem like such a high-minded thing. I think it's just saying, like, look, if we're going to finalize some block, then it must be that one of these grandpa participants saw it being a descendant, and not only a descendant, but a best chain descendant of a, block C or something that we already finalized.
That's kind of like Casper.
Yeah.
Yeah.
Yeah. Cool. Well, I'll tell you what, I would be happy to switch gears from consensus at this point, and if you guys want, I would definitely talk more about Grandpa next week too.
Yeah,
sure.
yeah, I'm done. I'll definitely look at it this week too.
Cool. Yeah. I think pretty sure I posted that link. Yeah, I did. That's in our collab channel, consensus channel.
Should I start another recording?
Sure.
Yeah, Tomislav, you had something to show, right?
Oh yeah. I have a.
Should I start another recording, or we still?
Yes, please.
So hey, I want to say at the outset though, I have to go in 20 minutes, so I hope that's sufficient time to cover.
Oh yeah.